Okay, so I did find some great information on the internet, and wouldn't you know it, it's at the same website as the company that I bought these from. They have some excellent information on the website specific to capacitors and resistors and stuff like that, and they have a great page on using safety caps. And without going into a lot of detail, because there is a lot of detail there, a very good explanation of them. There are X-type caps, capacitors, and Y-type capacitors, and they give a great mnemonic for how to remember which is what and where you use them. And the idea is the X-type capacitor is designed to go across the line. See the X? Aha, X-type across the line. The Y-type is intended to go line to ground. I believe you can use X anywhere. And I'm not sure I saw any Y types. How critical is the size here anyway? I don't think it's that critical, frankly. 0.02, 0.05, 0.1. So what I've got here is 0.02. And what I'm thinking of doing is, because it can be done in this radio quite easily, is instead of doing what they did originally, which was line to chassis, one side line to chassis, I'll do both sides to chassis. And you need to do that with a Y type. I'm going to go through them again and see if I can pick up 0.02. 0.01. An idea of the size that I need. Now, I don't have any of these blue ones that are physically larger than that. So let's scan through the yellow ones. Isn't this exciting, sorting through stuff? 0.1 Y. 0.01. The only problem with a little paper slip is that often it's in places you can't read it. Oh, there's a 0.02 Y 5. 0.022 Y. So that's what I'm after. I'm after 2.022 Ys. I only got 3 of them in here. Pretty big. The 0.02 ones are these big orange ones. They're too big to go in there, for crying out loud. 0.01. And what have I got a lot of? 0.01x capacitors. I'm going to do these. Look at how nicely these are going to go. It's going to go real nice. I'm going to be taking out that white wire, so I don't really want to solder this into it too much. Or it's going to be just a little awkward here. When I go to change the white wire. So I'm trying to put these down in the bottom of the connector. Now, frankly, since I haven't been paying close enough attention to these filter capacitors on the radios I've been working on, a lot of them have lots of noise in them. Crying out loud, it could have been coming in on the power line, and I really haven't been dealing with it properly. Lots of heat, lots of solder. There we go. Lots of heat. And there we go. Now, if I've done this right, flip these up. There we are. Still need to tighten that. Okay. So there we are. I have now replaced every paper capacitor, he says carefully as he scans through the radio very carefully. They're all gone. There's some mica left in there. And of course most of the original resistors are still in there too. But I think we're ready for another test. I think we are. Don't see any reason not to. So let's do that. I'll have to organize all my capacitors. Actually, I have to organize all my small parts again because my kind of stuff aren't ready to handle this many different types of parts. Got to come up with some new way to store them all. So I'm just going to vacuum this up because it's kind of bothering me a little bit. Now, let's see how we are for time. I have just enough time to pull off a test here. So let's do that. Okay, incidentally, my signal generators are running. And plugged in. Here is plugged in. Okay, I have my hot chassis warning system, which I need to fix here better. Should not be a hot chassis in this radio ever. And that's exactly why you want to put on a warning thing. Because if you have an expectation that something will never happen, you will not be prepared for it when it does. And just cleaning up a little bit before the power. Always a good idea to declutter. Also, in case something starts happening, something scary starts happening, you want to be able to make the right decision quickly, and that might be if your workspace is covered with stuff everywhere, and you can't figure out what to do quickly. Or you very quickly make the situation worse because there's just too much junk around. Or the junk is making it hard for you to see that there's a screwdriver sticking in the back of the radio. So, but that's not the case. We're all ready here. We're ready, ready, ready. Ready, ready, ready. Okay, I'm not going to bother putting on the separate power supply and do the power up that way. I'm going to power it right up. I am going to this is the 60. I'm going to undo the 60 watt light bulb. You can't see me doing it. I'm going to restrict it higher. Okay, so the power reaches the radio through a 40 watt light bulb. That's quite a restriction on a radio like this. Why am I doing that? No really good reason, just being cautious. Voltmeter's on. Leads are connected. Ground and positive. And you know what? We're going to read the positive voltage of the other capacitor. The other big filter capacitor that I put in here. Because that's the one we're actually concerned about it charging up. So hopefully what we'll see is the meter actually comes up fairly slowly here. It doesn't leap up, indicating I've shocked the radio with too much charging current in the second capacitor, which is about 4 times the size it's supposed to be. Something like that. So, are we ready here? Three times the size, I guess. I think we're ready. Switch is on. Volume is turned down. Seems a little loose. And I'll arm our power supply. If I just tip this up just a little bit further and over, you can see the switch here. Throw this down. You can't see the light bulb here. I wonder if I can just change things a little bit. You can see absolutely everything. Okay. So the light bulb is this lower one. It's a little hard to see here. Voltmeter is going to show the supply voltage. This is going to show B+. This is set on the 500 volt scale. And we'll now apply heavily restricted power. So that light should come on pretty bright back there. Absolutely nothing happened. Absolutely nothing happened. Hold it, hold it, hold it, hold it, hold it. What, why would that be? Oh, it did happen. It's just stupid. I'm just stupid. Let's try it again. There we go. So you saw the voltage come up fairly slowly here, which is great. It didn't leap up. It's up at 350. Now falling back as the tubes begin to drop B+ power. And you see a big fallback on this capacitor because there is a resistance in the way, and that's the field coil of the wow, that fell all the way back to 230 volts from 350. We have to keep our hand on that, or keep checking the temperature of the field coil. See how that's doing. Our supply voltage is very low. I can only estimate it from this meter here, where my finger is. It's at about 75% of line voltage, so it's going to be around 80 volts right now. 80 volts. 80 volts, not very much. There we go. Hey, that's not a little bit different. Okay. Just trying to figure out where that reflection's coming from. Okay. So that is good. Let's turn up the volume. Okay. It sounds like a radio receiving noise. Well, we're going to increase the supply voltage by screwing in this light bulb. So watch what happens now. Okay. So now if you look close, you see both those light bulbs are still glowing. And I've got about 100 watts worth of light in there. You can kind of think of it that way, in series with the supply. The voltage is running around 85 95% of line voltage, still under 100 volts. We have the signal generator connected right now to the antenna. We are pretty sure we're on AM band. I think we're tuned about that's way there. Let's see if we can find the signal generator now. It's putting out a strong signal. Okay, just calibrating the unit. Okay, pretty strong signal. Strong signal down there. Now it's really pumping it out. 900. Can we find it? Come on, radio. Hey. There it is. Oh, big thumbs up on that. It's a very strong signal. It's not much of a reception, is it? That's what happens if I pull the antenna right off. So, I think some alignment is really in order for this radio. Big time. Let's give it the full juice now. Yes, I'm going to put these on. I really don't expect anything to explode, but voltage now is full. I'll turn the volume down a bit. The speaker's aimed right at my microphone, so this is probably pretty loud for you. Let's check a couple things. Temperature of the field coil. (19). Temperature of my bench. 17. Temperature of the high wattage resistor. This is tricky to measure. Uh-oh. 8 degrees C. Too hot. That's too hot, man. It's too hot. What is so hot in here? Oh, wow. 91. 80, 91. That is too hot. I don't even stick my finger on it to verify. That's telling me that there's too much current flowing. Nice. Ooh, careful there, Jimmy. I'm sticking my hands right on the plus lead here. Oh, what was that? Ready, stand back. Okay, I cut the power. Isn't that the thing we were trying to get rid of all this time? Is that terrible static crashing when it warms up? What happened? Oh, all these capacitors changed and boo-hoo. I mean, that's even worse than phooey. I'm on phooey, I'm into the boo-hoo range now. So, yikes. I take it the fun is not over with this radio yet. I must go and attend to other matters of life, so we'll leave it sit for a while and time to think about what my next move is going to be on this, short of changing all the resistors at this point. Yikes. So, hey, thanks a lot for watching this series. Hope you're enjoying it. And we will get this radio working really well, I'm sure of it.